Okay, so today we are moving on from arithmetic sequences to geometric sequences. And for that, we still need all these key variables that we talked about with arithmetic sequences, but there is one that is different. So we have a sub 1, and as a reminder, that is our first term. And R is the new one, so R is what we call the common ratio. And the common ratio means the number that we multiply by each time. Okay, so that's our key difference. Instead of adding the same number each time, like we had a common difference for arithmetic sequences, now we have a common ratio because we are multiplying by the same number each time. N is still just talking about the term or the position number, so where it's at in the list. And then A sub n, remember we pronounce that A sub n because n is down in our subscript, and that is just talking about any term, so the nth term, and what that value is. And then A sub n minus 1, we think of that as the term before n, or we use the words the previous term. Okay, so just like we needed these to come up with our rules for arithmetic sequences, we're going to use these to come up with our rules for geometric sequences. So looking at this example, we have the sequence 3, 6, 12, and then it continues from there. So our first term is 3. Then to get the next term, the pattern is 3 times 2 to get 6, then 6 times 2 to get 12, and we can see that the next term would be 12 times 2 to get 24, and then 24 times 2 to get 48. And I think you guys could probably fill out the rest of the pattern continuing down. Then we get to our nth term, and we have to figure out what are we doing each time to get any term A sub n, and all we're doing is taking the previous term, which our notation for that is A sub n minus 1, and in this case, every time we were multiplying by 2. Okay, for our general recursive rule, we want to do the same thing we did last time. We have to give a starting point. So we have to say A sub 1 equals whatever the first term is, so we know where to start. And then the second part of it is just what we came up with here. To find any term, A sub n, we take the previous term, A sub n minus 1, and we multiply by, in this case it was 2, but in general, any sequence we're multiplying by the common ratio r. Okay, so there is our recursive formula for geometric sequences. Moving on to this table, now we have same pattern, 3, 6, 12, but we've got a little bit more in our table. So again, we're multiplying by 2 each time to get the next number. So to find the fourth term, we know we'd have to multiply 3 times 2 times 2 times 2. And if we are multiplying by 2 3 times, we can change this to 3 times 2 to the third power. 3 is our first term in this case, so we can rewrite that as A sub 1. And r is 2, so we can do times r times r times r. Again, simplifying that would just be a sub 1 times r cubed, and then the term value, if we look at this, 3 times 2 times 2 times 2 would get us this value of 24. Okay, so again, if you need to continue filling this out to see the pattern, you can go for that, but we know, based on last time, we can generalize what is happening. So to find any term in our sequence, that nth term, all we're doing each time is taking the first term and we are multiplying by the common ratio. And to get the fourth term, we multiplied by that common ratio 3 times. To get the third term, it was 2 times. To get the second term, it was only 1 time. So it is always 1 less than the term number. So now this time, the n minus 1 is our exponent. So we are always multiplying by r n minus 1 times. So that is our exponent. Okay, so that is our explicit formula to find any term in a geometric sequence. We have a sub n equals a sub 1, which is our first term, times the common ratio, whatever it's multiplying by each time, with this exponent n minus 1. So as you type this in, make sure n is in your subset, 1 is in your subscript, but then n minus 1 is up here in your superscript because that is our exponent. Okay, recursive and explicit still mean the same thing. So recursive formula, as we learned with arithmetic sequences, can be used only if we know the previous term value. So if you know the first 5 and just need to find the 6th term, go ahead and use the recursive formula. But if you only know the first 5 terms and need to find the 100th, you want to use the explicit formula because that can be used to find any term value. So now we've talked about the 2 main types of sequences that we're looking at, arithmetic and geometric. As a reminder, the difference between them is arithmetic, we are adding each time by the same number, and geometric, we are multiplying. Each time by the same number. So really the only difference that changes in our rules, this one shows we are adding the common difference, d, every time, and this one shows that we are multiplying by the common ratio, r, every single time.